So in studying the occurrence of genetic characteristics, the following sample data were obtained. At the 0.05 significance level, tests claim that the characteristics occur with the same frequency. So we do have a table of frequencies over here. We are going to assume it's a simple random sample. If they all occur with the same frequency, each expected frequency is going to be at least 5. And we do have our frequency table given over here. So let's see what these numbers add up to. We need to know the total number of people that were questioned over here. So we have 28 plus 30 plus 45 plus 48, 38 plus 39. Okay, so we have a 228 total. That's our N. Since each occurs with the same frequency, how are we going to find the expected frequencies? Because these are our observed ones. We're going to add in the expected ones. Well, they each occur with the same frequency, so we're going to take N and divide it by K. What is K? Yes, we have 6 categories over here. So 228 divided by 6 says each expected frequency is 38. So I'm going to put 38 down here. All right, how should I put my expected and my observed frequencies in my calculator? What do you suggest? Let's make a list. So we're going to do stat edit. Make sure you clear out your lists. We're going to put the observed frequencies into list 1 and the expected into list 2. So 28, 30, 45, 48, 38, and 39. Okay, then each one of the expected ones is 38, so we're going to fill that in for each category. Make sure your rows line up. We have the same number of rows in each one. Okay, let's set up the null hypothesis and the alternate hypothesis. So over here we have each occurring with the same frequency. That is our assumption, a null hypothesis. So we're going to say P1 is equal to P2 equal to P3. So saying all these different probabilities are the same. And then the alternative is at least one P is different. So it doesn't mean that they're all different, but at least one. Okay, we find our tests as usual under stat test. And now we're going to error up to the chi-square goodness of fit. So GOF stands for goodness of fit test. We're going to say our observed frequencies are in list 1. Our expected frequencies are in list 2. Our degrees of freedom is equal to K minus 1. So K is 6, so degrees of freedom, change that to 5. And then hit calculate. Okay, so this gives us our chi-square test statistic. It gives us a p-value, gives us our degrees of freedom. And so let's write these down. So our chi-square test statistic is 8.263, always rounded to 3 decimals for chi-square. Our p-value is 0.1423. We're comparing that with our significance level. This is greater than 0.05. So when the p is low, we're going to reject the null, but this p is greater. So that corresponds, a larger p-value corresponds with the usual value for the chi-square. And therefore, our conclusion is we're going to fail to reject the null. Okay, so we're failing to reject the null over here. Our wording is very similar to before. Let me see if I have my wording here. All right, so our original claim was in the null because it says test the claim that the characteristics occur with the same frequency. So that means our claim is in the null, and therefore we're right here. Right, claim is in the null. Where this one would be claim is in the alternate. We fail to reject the claim, therefore there's not sufficient evidence to warrant rejection of the claim. Claim that all the characteristics occur with the same frequency. Right, that's our conclusion. So this is the first type of goodness of fit. So this is where each occurs with the same frequency. We simply look at our total n divided by the number of categories in order to get the expected frequency. Our second example we're going to look at, this is going to have different probabilities. And so it's going to be kind of a little different method. So let's go down and look at the second example. So it says among the 4 northwestern states, Washington has 51% of the total population. Oregon has 30%, Idaho has 11%, Montana has 8%. A market researcher selects a sample of 1,000 subjects with 450 in Washington, 340 in Oregon, 150 in Idaho, and 60 in Montana. At the 0.05 significance level, test the claim that the sample of 1,000 subjects has a distribution that agrees with the distribution of state populations. So we're going to look at, is P1 equal to 0.51, and P2 is equal to 0.3, P3 is equal to 0.11, and P4 is equal to 0.08. So we're going to write down each one of these. We're going to have the observed and the expected frequencies. So Washington, we have 450. We have Oregon has 340. We have Idaho has 150. And then Montana, 60. So our null hypothesis is that P1 is equal to 0.51, P2 is equal to 0.3, P3 is equal to 0.11, and P4 is equal to 0.08. Our alternate is at least one P is different. So it doesn't mean that they're all different, but at least one is different than what we would expect. Okay, so now we're going to look at those percentages, and we would look at, if we have 51% of the 1,000 subjects, we would expect that many to be chosen from Washington. So what is 51% of 1,000? (51% of 1,000) is 510. So that's what we would expect from Washington. Okay, 30% from Oregon. So 30% of 1,000 is 300. 11% in Idaho, 110. And then 8% in Montana, 80 over here. So those are our expected ones. Put the observed into L1, expected into L2, and let's calculate the test statistic. All right, I have to enter them first. So let's clear out our old lists, and we're going to put all right, so we have 4 categories. Our degrees of freedom in this example are 3, just k minus 1. So go to stat, test, error up to chi-square goodness of fit test, observed is an L1, expected in L2, degrees of freedom we just said is 3, and then go down and calculate. Okay, our test statistic, chi-square, is equal to 31.938, rounded to 3 decimals. So this is a pretty large test statistic. Our p-value is 5.4 times 10 to the negative 7. So if we round it to 4 decimals, this has 6 zeros before the first number. So this is approximately 0. So when the p is low, we're going to reject the null. The other thing we can look at is actually our critical values. So we didn't pull that up for the last example, but let's just do it over here. So remember, critical value, we have to look at, is it a left-tailed, right-tailed test? So we said chi-square, the goodness of fit test is always a right-tailed distribution. So we're going to look at the area to the right. And over here, our significance level is 0.05. So we're going to look at an area of 0.05 to the right. When you're looking at your chi-square distribution, sorry, mine is kind of marked up over here, looking at an area of 0.05 to the right and 3 degrees of freedom, you're going to go down to 7.815. So our critical value is 7.815. Our test statistic is at 31.938. So it clearly falls into that rejection zone. So we're going to reject the null. So we don't think that it does follow, it's not proportional to the size of each one of these states. Okay, so our original claim was in the null, right? We put our claim into the null. We want to see if it agrees with the distribution of state populations. And so we are on the top part again, and we rejected the null. So our wording is right here. There's sufficient evidence to warrant rejection of the claim that. That the sample has a distribution that agrees with the distribution of state populations, or maybe is proportional to the state size or percentages.